Today we're going to be talking about separating mixtures. Now we're going to use 3 different methods of separating mixtures in this lesson today. We're going to talk about filtration, distillation, and chromatography. Okay, so we're going to start off with filtration. Filtration specifically separates a liquid from a solid, and it is primarily used to separate the parts of a heterogeneous mixture, meaning we can discern the different parts. The parts are not evenly distributed. Now, usually what we've got going on here is we have some mixture of a solid and liquid. We're going to pour that into a funnel. Our solid portion will be collected on the funnel, and then the liquid portion will pour through. And we have 2 terms that we need to learn in order to discuss this adequately. So once again, we've got a solution here. Maybe there's a solid component that's precipitated out. We pour that in, and what happens on the microscopic level? Well, we have a filter paper, and that filter paper essentially has tiny little pores in it. And those little pores act like a colander when you're pouring your pasta water out into the sink. Anything that's a solid will remain on the filter paper. Anything that's a liquid will go through. All right, so we have a specific term for those 2 things, the solid portion and the liquid portion. The liquid portion is referred to as the filtrate. The filtrate is the liquid that flows through the filter paper. The residue is whatever is caught on the filter paper. So commonly this would be your solid component. And one thing that is important to note, that soluble substances will pass through the filter paper. So this means that if you have salt dissolved in some water along with some, let's say, sand, the sand would be your residue that would get caught on your filter paper. Your salt would remain in the filtrate. So how could we get the salt out of the water? Well, that would be a job for our next technique, which is distillation. Now, you might have seen distillation done like this, which was done by my forefathers back in West Virginia when you wanted to make some hooch up in the holler. But that's not what we're doing here in chemistry. Okay, we're going to be doing this type of distillation. It's a little more technical. It's also the technique that's used on a much larger scale in refineries to separate out components from crude oil. And we'll talk about that at the end of today's lesson. So how does distillation work? Well, distillation is mainly used to separate the components of a homogeneous mixture. We're talking specifically about solutions here. If we have a liquid dissolved in another liquid, we can use this technique. If we have 2 miscible liquids, for example, if we were trying to make perfume, one of the things one often does when you make perfume is you take, say, rose petals, and you would mix them with a mixture of water and ethanol. And you would chop up the petals in that mixture, and that would release those fragrant components from the rose petals. Some of those chemical components that make the fragrance of a rose go into the alcohol component because they're soluble in the alcohol. Some of them are soluble in the water. The parts that are soluble in the alcohol are the parts that we normally would want to harvest for perfume. So we could take that mixture, sit it, let it macerate, that's what it's called, let it really go into the alcohol in the water. Then we would use filtration to filter out the bits of rose petal. Then we would be left with just those chemical components that we've leached out of the roses. We could then take that alcohol and water mixture and put it in a distillation apparatus. Because the alcohol has a lower boiling point, the alcohol will boil off first. And if we know the temperature at which the alcohol boils, we can capture just the components that we want. And we can convert it back into a liquid so we can use it as a perfume using a condenser. So I'm going to show you what that looks like now. This is a distillation apparatus. So this would be our container. Oops, sorry. that has our rose petal, water, and alcohol mixture. Now we've removed the solid rose petals from it. All that's left is the chemicals that make the lovely smell of a rose. We heat that up over a flame here, and we have a thermometer, which is important because we need to know the exact temperature that each of these substances are boiling off at, because we want to capture only the components that we want. If we want to only capture the alcohol component, we want to stop harvesting that vapor when that has all boiled off, because we don't want to contaminate it with any of the water, or we've just defeated what we just did. Because the alcohol will boil off at about 80 degrees Celsius. We'll watch our thermometer. If that temperature starts to climb closer to 100, now we know we're getting water, and we don't want that. So as that vapor comes up, it'll come down this tube into our condenser. Now the condenser has water flowing through an outer jacket, and the gas flows through this inner tube. As it flows through that tube and that cold water is going around it, what happens is the vapor recondenses into a liquid, and we get our pure liquid here in our receiving flask. And if we do that right, we'll get only the component we want. Now we can also use this to separate out the components of a solid dissolved in a liquid, like when we have salt dissolved in water, and that's what we've got in this case. So here we have salt water, and we are going to want to take our salt water. We are going to heat that up. We are going to heat that up. We are going to boil off the water as steam. That water is going to flow down the condenser coil. It's going to collect here in our flask where we now have pure water. If we do that right, now we're going to be left with a pile of salt and a container of pure water, and that is how we could separate out the salt from the water. So we could end up with using distillation, which is a physical method of separation. We've got a homogeneous mixture, and now we have only salt and pure water. Now we can also separate a solid dissolved in a liquid. This is also how crude oil is separated from gasoline, and we're going to talk about that a little bit more. That's because gasoline has a lower boiling point than heating oil. When crude oil comes out of the ground, it's a mixture of all these different components, and we can separate those components based on their boiling points. Our third method that we're going to talk about is something called chromatography. You probably did this back in living environment class. Chromatography is used to separate the components of a mixture, usually when we have different components with different attractions for substances not in the mixture. And I'm going to show you an example of that now. So let's say that we are wanting to analyze some ink. Maybe somebody was forging checks, and we're wanting to pull that ink from some of the checks and see, was that check all filled out at the same time with the same pen, or were different portions of it filled out with different pens, which would indicate a forgery. We could take samples of that ink, place it on a piece of paper, and put that into a solution that would separate out the components of the ink based on their affinity for our solvent. If that was a water-soluble ink, we could use water. We might use something like acetone to separate it out if it was a more permanent ink. All the components of the ink substance will separate based on both affinity and based on size. The smallest components will go the furthest, the largest components will get held back, and this would allow us to compare different inks to see if they are the same. So let's take a look at an example problem. If we had a solution of barium nitrate and a solution of sodium sulfate are mixed and poured onto a filter, the solid remaining on the filter would be what salt? So let's start with barium nitrate. And we are going to add to that sodium sulfate. What would we get? Well, we would get barium sulfate, and got to make sure we're balanced. We would get 2 sodium nitrates. Now I'm going to ask you to use table F to determine which of these two components would remain on our filter paper. That's right. According to table F, our barium sulfate would be insoluble, so that would be left behind on our filter paper. Let's try another problem. By using filter paper, which of the following two could be separated? Very good. Our best answer there would be a solid in a liquid. That's the only way that we can separate a solid in a, well, that's the only thing that filter paper will separate, is a solid in a liquid. Two immiscible liquids, they'd both go through the filter paper. Two solids, nothing would go through, and two miscible liquids, they would both go through. Distillation is used to separate what? Our best answer there would be two miscible liquids with different boiling points. In order to separate something by distillation, their substances must have different boiling points. How can we separate gasoline into its components? Which of the three methods we discussed today would be best for separating gasoline? Excellent. That would be distillation. This is our last new lesson in our unit on solutions. Thanks a bunch, and we're going to be hitting review next.